Hi, we have few questions to do. So in this case, first thing I will notice, let's say that you are not given an alcohol. So that's something you will see right away. In that case, what you want to do, this OH from the same carboxylic compound and the H from the alcohol of itself gonna be take boxed out. So in order to make this intramolecular ester, what I would do is I count the numbers of carbon, one, two, three, four carbons, and fifth one is actually a colored oxygen, the red colored one, right? So that's what I would fill first, and then you have the number one carbon, the carbonyl, it stay the same, right? And then make sure the colored oxygen from the alcohol side is there, and boxed out water gone because we don't have alcohol. That's the signal for lactones, intramolecular lactones, right? Now we got it. And sulfuric is your catalyst, normal, yada yada there, right? Now this one, next to the carbonyl, alpha, beta, gamma. So that's how you say gamma lactones or cyclic ester. Now look at this question. This has a little bit another twist. So I just counted the carbons, right? And rather than labeling, I pay attention to the alcohol is oxygen 18 labeled. Now again, we box out normal way, remove the water, and now we can again redraw the carboxylic acid skeleton normally without the alcohol, right? And then we can bring down the alcohol into the other end, which is O methoxy OCH3. And in this case, 18 labeled oxygen gonna stay there. And then we just put the link, which is we boxed out, and this that will be linked to that, right? That's the idea here. Now you can try to label the ester just for practice, and otherwise watch the labeling or naming video. Here, this is a special one. When you are given sodium or lithium compounds, make sure you put a plus on the sodium or lithium. The other portion gets negative. Then that means it's the nucleophile. It's actually a strong nucleophile, OET minus. Now that one attacks the carbonyl. If you think about the logic to understand, and then somehow the OH is going to go away, let's say, and now we can draw the ester. In this case, the benzene rings stay the same, the carbonyl stay the same. Only thing we kind of remove the OH somehow. That will be connected by the OAT, right? Now this one also, you can kind of show the boxed out part, but it's not the sodium hydroxide. You never make sodium hydroxide in a reaction that way, right? So now you can say ethyl part is the front of the name, and then the benzoate because you start with the benzoic, right? Okay. The last question I chose, yes, we are given another compound. Alcohol is not visible. Then in this within the same compound you have five carbons, and I put a star for the oxygen because we don't put the same numbering. But here you draw the six-membered ring and put the ring oxygen, which is the star in the problem, right? And then carbonyl did not change, stay the same on the number one carbon. Now we are done with it, the bigger part. Let's do the old fashioned next to the carbonyl alpha, beta, gamma, delta. Now, because it's delta, this is called the delta lactone. So that's how you do it.